Hi guys, so I kind of got cut off in the last video, so I'm actually just going to make a second video here so I can spend a lot of time trying to explain this table here that was part of the slideshow. So we were talking about work. Work is something done by forces on objects, and a force can do either zero work on an object, it can do positive work on an object, or it can do negative work on an object. And this table is meant to explain which one it's going to be, or how you can tell which one it's going to be. So I talked about this the last video, so I won't spend too much time on it, but one thing you can always look at is the angle. When you draw the two vectors, so force and displacement, when you draw them tail to tail, if they form a 90-degree angle, then that force does zero work on the object. If they form an angle that's less than 90 degrees, so an acute angle, then we say that force does positive work on the object. And if they form an angle larger than 90 degrees, so an obtuse angle, then we say that force does negative work on the object. So I'm going to try to identify if a force does negative, positive, or zero work on an object in various situations. I want to show you that in this video. And to help, I'm going to try to draw some arrows out to help you better visualize the angles going on here. So in these situations, my blue arrow is going to represent the direction of the motion of the object, or the displacement of the object. And my red arrow is going to represent the direction that a force is pointing, that a force is acting on the same object. So actually, if I just take these two arrows right here, so this red force is acting on an object, and the object moves a displacement in this direction. Is this force doing positive, negative, or zero work on the object? What you would do is draw them tail to tail. So I'm just going to drag this over so it's tail to tail. And then analyze the angle between them. The angle looks pretty clearly less than 90 degrees. So going back to my table, if it's less than 90 degrees, then positive work is done. So this picture this is a random displacement and a random force, but this picture shows that positive work would have been done on the object by this force. All right, so let's get into some actual scenarios, simple scenarios. So I'm going to start with just picking up a ball. Okay, so there's a ball, and the experiment's very simple. All I do is pick it up. That's it. I picked up the ball. And what forces acted on this ball? Well, there was gravity and there was my applied force. So there was two forces on the ball. That means there were two works done on the ball, and I'm going to decide if each one of those works was positive, negative, or zero. Starting with, I'll start with gravity. So gravity does blank work on the ball. So that blank, I'm going to fill in either positive, negative, or zero. And you know what? I'll do the same thing for applied force. So my goal is to fill in those blanks. Okay, so I'll start with gravity. First of all, the blue arrow represents the displacement of the ball. So since the ball went straight up, I'm going to draw my blue arrow straight up. So that arrow represents displacement. And now if I focus on gravity, the red arrow represents the force. So the force of gravity is always straight down. So there's my gravity arrow. Now if I draw them tail to tail, and I look at what angle these two arrows make, well, it looks like it's 180 degrees. Okay, you take one arrow, you turn it 180 degrees, and you get the direction of the other arrow. So going back to the table, which category does 180 degrees fall under? Well, it falls under the greater than 90 section. So the answer for gravity is that it does negative work on the ball. Another way to look at it, I've written in words here, if the force is in the opposite direction as the motion, then it's negative work done. And yeah, the motion is one way and gravity was the opposite way. So gravity does a negative work on the ball. Now I can ask the same question about my applied force. So my applied force was up. Okay, my applied force was up. And the displacement does not change. The displacement is still up. So now if I draw these tail to tail, what's the angle in between those two arrows? Well, they're pointing in the exact same direction. So the angle between them is 0 degrees. So if I go back to my table, where does an angle of 0 degrees fall under? Well, it falls under the middle one. The angle is less than 90 degrees. Therefore, my applied force did positive work on the ball. Another way to say it is if the force is in the same direction of the motion, then it does positive work on it. And that was true about my applied force. So my applied force does positive work on the ball. All right, so that's example 1. Example 2, I'm going to make slightly different. Slightly different. So I'm still going to have the ball, but this time I'm going to start up here, and I'm going to throw it down. Okay, I threw it down. And you see it went really fast and hit the ground pretty hard. So I'm going to ask what kind of work the forces did on the ball while I was throwing it down. So this time, I'm going to replace these with my blanks again. Okay, it's still these two forces. Okay, it was still just gravity acting on the ball and my applied force acting on the ball. But what's the difference? Well, the displacement of the ball as I was throwing it down would be down. So I'll draw my displacement arrow down. I'll work with gravity first. So which way is gravity point? The red arrow represents the force. Gravity points down. Draw these tail to tail. So both arrows point down. What's the angle between them? It's 0 degrees. They're in the exact same direction. So this time gravity does positive work on the ball. How about my applied force? Okay, so the displacement while I throw the ball down is still down. My applied force is also down, okay, because I'm throwing the ball down, so my applied force is down. They point in the same direction. So applied force also does positive work on the ball. Okay, so that would be the answer to example 2. Gravity does positive work on the ball, and applied force does positive work on the ball when I throw it down. All right, another example that I was working on, I got kind of cut off. The last video was a ramp. Okay, so we simply have a ramp, and the experiment is simply a book slides down a ramp. Okay, that's it. A book slides down a ramp. So that's the situation we're analyzing. And I want to know if each force acting on the book did positive, negative, or 0 work on the book. So I'm going to change ball to book. And I'll put a blank here for now. There's no applied force this time. Okay, I wasn't pushing or pulling it, but there's a normal force. So we'll talk about the normal force. Put a blank here. And there's one more force acting on this book as it slides down the ramp. Do you remember which force that is? It's the force of friction. So friction does blank work on the book. Alright, so this is the problem we're trying to figure out. There's 3 forces acting on the book as it slides down the ramp. For each one, did it do positive, negative, or 0 work on the book? So first I'm going to adjust my displacement arrow. The displacement of the book, it slid down the ramp. So the displacement is on some kind of an angle that way, the angle of the ramp. Alright, I'll focus on gravity first. So gravity, my red arrow is my force. Gravity points straight down. So I don't really have to change this much. I'll extend it a bit. Alright, I'll draw them tail to tail. And I analyze the angle that they form. It looks like that's an acute angle. It's less than 90 degrees. So if it's less than 90 degrees, the answer is positive work. So gravity does positive work on the ball, or sorry, on the book. How about the normal force? Well, the normal force is perpendicular to the ramp. The normal force is perpendicular to the ramp, which actually also means that it's perpendicular to the displacement. So the normal force this time does, since it's a 90-degree angle, we have the special case here where it's 90 degrees, normal force does 0 work on the book. And finally, friction. Which way does friction point on the book? Well, friction is resisting the sliding, so friction would be pointing in the opposite direction of the motion. So if they're in opposite directions, it does negative work. So friction does negative work on the book. Alright, so those are the 2 examples that I wanted to show you. One thing I'll say is that some of you may be thinking right now, oh, normal force is always going to be 0 in every situation. Well, that's not true. Okay, that's not true. Sometimes normal force is in the same direction that the object moves. Sometimes normal force is in the opposite direction that the object moves. So do not always think that normal force will do 0 work on the book. And one other thing, you may think, oh, friction definitely has to always be in the opposite direction of the motion, so it does negative work. Well, actually, that's not exactly true either. Friction can sometimes be in the same direction of the motion, and I'll show you a quick example of that. Okay, so I have this box here. Now, if I just drag the box across the carpet here, yeah, friction is resisting it. So friction is in the opposite direction of the displacement, so it does negative work. But hey, this is, watch this. I can make the box move towards me with friction acting in the same direction, like this. Alright, so there's a little trick there. So in this last situation, friction and the displacement of the box are actually in the same direction. So friction does positive work on the box. So there's no automatics here. Okay, there's not really anything where you can say automatically that's the answer. You should analyze each situation really carefully.